pumpkin pasties have the following demand curve. So we're given this thing, which is representing the preferences for pumpkin pasties. You'll remember a demand curve tells us the quantity demanded given a price. So we plug in a price on the horizontal axis, and then that tells us plug in a price on the vertical axis, and that tells us on the horizontal axis the quantity demanded. So how much people wish to buy at that price. So in this question, we have prices in galleons and quantities in thousands of pasties. So those are the units we're working with. So the first question is to plot the demand curve. So we're given a nice little graph here. I'm just going to use P and Q on the vertical and horizontal axes. And then we're asked to find the vertical intercepts and horizontal intercept. So the way we do this, we're given a little bit of a clue here, is we plug in a quantity of 0 to find the vertical intercept. So if you look at this graph, the vertical intercept, this point here, is really just where quantity is 0. So to find it, all we have to do is plug in a quantity of 0. So we just take the demand curve, 1 over 6 times 0, and this gives us 17. All right, so 17 here. And then on the horizontal axis, to find the horizontal intercept, the same thing applies, right? We're just finding where the price is equal to 0. So that's going to be this point. So vertically, it's the point where price is equal to 0. So this is a little more involved, but not by much. So we have 0 equal to 17 minus 1/6 times Q. So this is our relationship, and then all we have to do is solve for Q. So this is 1/6Q, then we just add 17 to both sides. So, we add 1/6 times Q to both sides. So it gives us this thing. And then from here we just multiply by 17 by 6. So this is Q is equal to 17 times 6. And this thing, that's a number I have a solution for. That thing is 106. Okay, so on the horizontal axis, we have a horizontal intercept of 106. All right, so those are the intercepts, and then we can just connect this. We know this is the equation for a line. There's nothing with the exponents going on here. There's no just a linear relationship. So this is our demand curve. And if we'd like to, we could put this as pumpkin pasties. And then we'll call this the demand curve. All right, so nice. Basic setup. So the first quantity question is to find the quantity demanded at a price of 10 galleons. So the way to plot this is just to pick a point that's pretty close to 10. We'll put 10 here, and then we'll draw a horizontal line representing the price of 10. And then we'll find the quantity demanded at this price. So we're essentially plugging in a price into the demand curve, and that's going to tell us a quantity demanded at that price. Remember, the demand curve tells us all of the possible price quantity combinations that represent preferences. This is just telling us a particular one, the quantity demanded at a particular price, how much people are willing to buy at a price of 10. All right, so to do this, we just take our demand curve. We have 10 is equal to 17 minus 1 over 6Q, and then we just solve for quantity. So this is, we have 1/6, so we're going to add 1/6Q to both sides. And that gives us, we have 17 minus 10. So we're going to subtract 10 from both sides, which is equal to 7. So then this is Q, our quantity demanded at this price, is equal to 6 times 7. And that number is 42. So we have 42 is our quantity demanded, 42 here. We'll just put a box around this. So our quantity demanded at a price of 10 is 42, and we can just plot that. All right. So the next thing is to find the area of consumer surplus at this price. And just like we've talked about, we want to find the extra value, so the difference between what you're paying at a price of 10 and what you'd be willing to pay according to the demand curve. And we need to do that for every quantity. So graphically, this looks like the area of a triangle. We're looking at every individual unit that's actually exchanged. Remember, nothing above 42 is being exchanged. We found how much people want to buy, and that's given to us by 42. So for all of the units that are being exchanged, we have some difference between what people are willing to pay with the demand curve and what they're actually paying with the price. So this is our consumer surplus, is this triangle here. And so what we're going to do is just find this area. So consumer surplus is this triangle. A triangle has an equation which is height times base divided by 2, or multiplied by 1/2. So this thing, we have height, which is 17 minus 10. That times 42 times 1/2. I'll rewrite this one more time, but this is, the type of thing you can just put into a calculator. So this is 7 times 42 times 1/2. So at this point, you just plug this into a calculator, and when I do that, I get 147. Okay, so this is our consumer surplus at a price of 10. All right, so the next part of this question is to plot and find the quantity demanded at a price of 5 galleons. So just like we did with 10, we're going to plot this at 5, draw a horizontal line, and then we're interested in this quantity here. So the way we do this, as we did before, is we take 5 is equal to 17 minus 16Q. And then from here, we just solve. So this is 16Q is equal to 12. And then Q is equal to 12 times 6, which, as you plug this into a calculator, this is 72. Although you also could do this in your head if you like. But a calculator in this case is A-OK. All right, so we'll just put our number 72 right here. So in the next question, we're asked about find the area of consumer surplus at a price of 5 galleons. So the thing is, price has gone down. So price has gone down. Quantity demanded has gone up, which means we're buying more. So more things will have consumer surplus, and we're paying less for each one of them. So each item that's actually being exchanged will have a lower price, which means consumer surplus for the things that were being bought and sold before now have more consumer surplus. So price has gone down, quantity demanded has gone up, consumer surplus has gone up. So I'm going to call this new triangle, this big one, we'll call this, I'm going to put it on the outside here. This is CS prime. Okay. And I'm going to, just for now, I'm going to write this as delta CS, which is, we're going to come back to in question 6. It's this like weird trapezoid area. Call this delta CS. We're going to try to find this area in a second. But for now, all we're interested in is this entire, the entire area of this new triangle. So to find this, CS prime, this is equal, one way of writing this is that it's equal to the old CS plus this new trapezoid. The area of this thing is just a really big triangle. And again, this is height times base times 1/2, which is equal